Now take a look on next concept. Now the next concept is Dvajang Sutra. Now this concept is also new for us because we already learned about it in class 8. So now take a look on it by taking an example. Divide 592837 by 119 with the help of Dvajang Sutra. So what we are understanding, first we are writing it as according to question we have to divide it by using Dvajang method. Then its solution as below. Here main digit, which is generally said to be Mukhyang. The main digit or Mukhyang equal 100. You all know why I are choosing two digits. Generally the main digit is single. We know that generally we are using the main digit as single digit. But there is also an exception for it when when one will become, because when one will come we can't choose one as a main digit because one is dividing with each digit easily, we are getting the same number again. So what the result we get from it, it is the similar. So due to this, whenever one will become in the front of Mukhyang, we are taking two digit. So as it is 119, we are taking two digit 11, we are not taking the single digit one. And on other cases, if here is 219, we are taking 2 as Mukhyang. If it is 319, we are taking 3 as a Mukhyang or 3 as a main digit. But when it comes to 1, as a 1 is divided by each and every number easily, and we get the same quotient again. So whenever 1 is come, we are taking 2 digit as a Mukhyang, and in other cases we are taking a single digit. Now after it we have to move on the flag digit, or which is generally said to be Dvajang. The flag digit is equal. The rest of part of the divisor is said to be flag digit or Dvajang. It is written as the first we writing the main digit and after we writing the flag digit. As the flag digit is here only once, only a single number, so one or a single number will be moved in the third column. If it contains two digits, we are sending two digits in the third column. Now you can see that here the main digit is 11. Now we have to divide it. Now here the main digit is 11 and here the first digit is 5. So it can't be divided by 5. What we have to do, we are taking two digits. So at place of 5 we are taking 59. Now what we are doing, we are writing all the steps here. First 11 divided by 59. Now how many times it will divide? It will divide by 4 times. We are getting 44. When 59 divided by 11, the remainder will be 15. Now the 15 will be written at this place. Now and 15 will be written at this place, and the quotient we are getting, we are writing it at the quotient place. Now we have to need a new divisor. For new divisor, what we have to do, here the 152 and the next digit is 2, so 152 will be, it becomes 152 minus. Now here the work of flag digit will becomes. So what we have to do, you can see that here the flag digit is 9 and the quotient we are getting is 4. So 9 multiplied by 4 equal 36. What you have to do, whenever you divide any number, you have to multiply its quotient by the flag digit and minus it from the new divisor. So what we are getting, 152 minus 36, the answer will be 116. Now the new divisor is 116, it is not in negative, so we are not cancelling it and we're going one step back, it is positive, so we are moving forward. What is it? Now the new divisor is 116 and we have to divide it by 11. Now you can see that when we multiply 11 by 10, it equals 110 and it is divisible by 116. But we only can choose digit from 0 to 9. We can't taking a two digit number. So we can't take the 10 at this place, we are taking the 9 because 9 is a single digit number. When we multiply 11 by 9, it becomes 99 and 160 minus 99 equals 17. What happened? Now we are writing 17 at this place and the quotient we are getting, we are writing it here. Now we are getting two number of our quotient, 4 and 9. Now what we have to do, we have to repeat the same step. Now here the 17 and the next number is 8, so it is becomes 178. Now we have to subtract it from by multiply it by Dvajang and our quotient. So 9 multiplied 9 equals 81. So 178 minus 81 equal 97. It is also positive, so we moving forward. So now 97 is divided by 11. How many times it will be divided? It will be divided 8 times. After dividing it, the remainder will be 9 and the quotient will be 8. We are writing quotient at the quotient place and we are writing the remainder at this place. Now the new number will be 9, called as 93. What we have to do? We have to repeat the same step. Now 9 multiplied by 8 equals 72. 93 minus 72 equal to 21. So our new divisor is 21. So what we have to do? We have to divide 21 by 11. What will be happen here? When we dividing it, you only divide by 1 times and the remainder is 10. Now we are writing 1 at this place and we are writing 10 at this place. Now you all can see we are moving in the third column. So now there is no new divisor or required. Now the concept of remainder, because the third column is only for remainder. Now what the new number is 107 and we are repeating the same step. We are multiplying the Zhejiang with the new quotient we are get. 9 multiplied by 1 equals 9. 107 minus 9 equal to 98. So the remainder will be 98. Here you all can see it is clear that it is positive. So we are writing the same equation here. 107 minus 9 equal to 98. Now this is the second column is our quotient column and the third column is our remainder column. So the quotient of this division is 4981 and the remainder is 98. I think you all get the point. So let's move forward. The next topic or next part will become square by Vedic method. Now this is the next part. It also contains many subtopics. We learn about them in detail. Sutra Ekadiken Purvan. It also Sutra Ekadiken Purvan. And now there is you all can see a note or a condition for it. Using this sutra, the square of the number in which digit on one's place is a 5 unit digit. So what this method is applicable? This method is applicable only for those numbers whose ending digit is 5. So we understand it with the help of example. The example is find the square of 15 by Ekadiken Purvan. So what does the Ekadiken Purvan mean? We already talked about it. Eka representing 1 and Diken means more. We are taking 1 more. So in the case of 15 square, we are taking 5. The 5 is the condition for it. We are don't taking 5. The other than 5. What does the digit is? 1. Here the other digit is 1. So we are taking 1. We are writing it here. And Ekadiken means once more. So 1 plus 1 equals 2. So 1 multiplied 2. And we are using a slash here to separate them. And here the right side or the 5 square is 5 into 5. We have to multiply the same number. It is similar to the multiplication of Ekadiken Purvan. You are seeing that 15 square means 15 into 15. Here the similar digit we are leaving the 5 here and we are taking only 1 because here is a similar digit 1. Here we are taking 1 in the same pattern. 1 more, 1 into 2 and slash the rest of digit multiply in the right hand side. So 5 will multiply 5 equal 25 and here 1 multiply 2 equals 2. The answer is 225. This method same is applicable for if you are taking 105. And what you are doing, we have to find the square of 105. What we are doing, that we resting the 5, other than 5 their number is 10. We are taking 10, 1 more than it is 11. So 10 multiply 11 and we are using the slash, and after it there is what we have to use. After it in the right hand side we have multiply 5 into 5. So 10 into 11 equal to 110 and 5 into 5 equal to 25. Then the answer will be 110 and 25. So this is the pattern of solution of Ekadiken Purvan. Now I think you all understand about how you can all find square by using Ekadiken Purvan. And one condition is must applicable here. It is only apply for those numbers which ending digit or which unit digit is 5. Also you have to write conclusion in the solution. Hence the square of 15 by Ekadiken Purvan is 225. Now let's take a look on next concept, Subsutra Anurupe. Now this concept is also having a condition. This is only applicable for 2-digit numbers. Now we understand it with the help of an example. Find the square of 41 by subsutra anurupe. So what is it is? As first we what we understanding from the question, we writing it here as according to question we have to find the square of 41 by using subsutra anurupe, and then its solution is below. What we have to do, we have to make three columns. In the first column we are taking the tens digit, in the second column we are multiplying tens and ones digit, and in the third column we are taking the ones digit. It means it is a 2-digit number as a condition will be applied for it. So what you have to do, you have to place the tens digit in the first column, the ones digit in the third column, and multiply these digits in the second column. In the first column we are squaring, so square of 4 is 16, and in the third column we are squaring 1, the square of 1 is 1, and now in the second column what we have to do, we have to do 4 multiplied by 1. So what happen, we get 4 multiplied 1 equals 4. So we have to add the same digit again. Here the result is 4, we are adding 4 in this also. So what is here, 1 square equals 1, so it is similar. 4 plus 4 equals 8, and 4 square equal to 16. Now you can see that the right side is contain only unit digit or only a single number of ones digit, so we are not sending any digit in forward. Now the final answer is 1681. Hence the square of 41 by subsutra anurupen is 1681. Now we are moving on the next concept. The next concept is upsutra yavadunam tavadunam vargacha yojat. Now this also sounds as Nikhilam method because it also contains two different sub methods. The one is base method and another one is sub base method. Now we also have taking to look on this note. This note is this sutra contains two methods. As I already told, the first one is base method and the second one is sub base method. And there is a need of difference in these formulas. How you can all find the difference? You can all find the difference by using this formula: difference equal number minus base or sub base. Here base or sub base are used as which method we are using. In the base method we are subtracting base, and in the sub base method we are subtracting sub base. We understand it with the help of an example. What we have to do, find the square of 17 by upsutra yavadunam tavadunam vargachayoj. So what its solution is, first we have to write what we understand from the question. Here according to question we have to find the square of 17 by using upsutra yavadunam tavadunam vargachayojat or Nikhilam method. Then its solution is below, because in examination the question will also be appeared as find the square of 17 by Nikhilam method. So you don't have to worry that we don't read about Nikhilam method. Upsutra yavadunam tavadunam vargachayojat is also called Nikhilam method. So let's come back to the example. What we have to draw, as we noted, what is the formula? The base method is equal number plus difference and difference is square. So here base is, now you can see 17, it is near 10. So here the base is 10, we are not taking sub base, so there is no sub base digit. The base is 10 and the difference is, what we have to do for finding difference, we have to apply this formula. What is this formula? Number minus base or sub base. Here we are using base method, so we are subtracting base. So what we are getting, number is 17, base is 10, so 17 minus 10 equal to plus 7. So we are using this formula. Now substituting these values in the formula, we are getting 17 square equal, here the number, what is the number, is 17 plus difference. What is the difference? Difference is 7, so 17 plus 7, and difference square means 7 square is 7 square means 49. So 17 plus 7 equal 24 and 7 square equal to 49. Here now you can see here the base contain only single zero, so we are taking only single number here, and the other digit will be sending forward. So 4 will be sending forward, so 4 plus 4 equals 8, so 289 is our final answer. So hence the square of 17 by upsutra yavadunam tavadunam vargachayojat is 289. I think you all know, or I think you all get the concept. So let me move on the next concept or next part of this method, because it will divide it or it contain two methods: sub base method or upadhar vidhi. Now what you have to do here, we are understanding it with help of example. Find the square of 225 by upsutra yavadunam tuvadunam varga chayoja. Now you can see there is no change in the question. If you are saying the previous question, the question will be same in the both cases. But what does the change here? The change is the digit. Now this is a much bigger change. How can, when we are talking about 17, it is near the base, so we can easily find it. But when you look on 225, what you get, it's near 100. We are taking the Nichilam base, the base will be near 100, but it is not near 100. When we are finding the difference, it is around 125. So when we are finding square of 125, so why we can't finding the square of 225 easily? Due to this, we are requiring sub-base method. What we are doing here, you can understand it with the help of this example. First you have write what we have understand from this question. What we have to do, we have to find the square of 225 by using upsutra yavadunam tavadunam varga chayojan. Then what here, as we noted, sub-base method. Why we are applying here sub-base method? It is not near the base. When it is near the base, it will be around 105, 110, 115, but here it is 225, so it is much more than the base itself. So what you have to do, the sub-base method is sending sub-base digit multiply number plus difference, and difference is common. Now you can see it is similar to the formula of Nichilam method. You already know about the Nichilam method. There is, we are using the derivation, and here we are using the difference. In that case, the derivation may be differ. So in the right hand side we don't squaring it, but here the derivation is same, so we are squaring it. So only one change in the base and sub-base method, only a new digit will become sub-base digit. Now what you have to do, we are finding the base. The 225 is near 100, so the base is 100. Sub-base is, now what does the sub-base means? We have to multiply the base by a number by which it will be near to the sub-base. Here we multiply it by 2, then answer is 200. So the sub-base is 200. Now from which or by which digit we multiply the base, it is called sub-base digit. So here the sub-base digit is 2, and now we find the difference. Here the difference is the same case of the previous. The first is 225, we minus 225 minus sub-base, not here base, here sub-base. 225 minus 200 equals to 25, so difference is 25. We are using the above formula, or we are now substituting these values in the above formula. What we are getting, first is sub-base digit, so the first digit is 2, then we are taking number plus difference, so number is 225 and difference is 25, so 225 plus 25 is equal to 250, and when 250 multiplied to equal 500. Now 25 square, we all know what is the square of 25, it is 625. Now here you can see, as we are taking the base, here is only 2 digits, so we only can take 2 numbers at the right hand side, and the other numbers will be sending forward. So here the 6 is the third digit, so we are sending it forward. When 500 plus 6 is equal to 506, and the 25 of right hand side, the final answer is 50625 or 50,625. Now we are writing the conclusion. Hence the square of 225 by upsutra yavadunam tavadunam varga chayojat is 50,625. I think you all got the method. Let's move on next concept, square by Vedic method. Now we are finding the square by Vedic method with the help of Sutra Urdhava Triyak Bhyam, or it's generally called Dvandiyog. Now this is very easy method. There is no condition for it. You can use this method for any digit. You can find it as much as large number by, or you can by using this method we can find the square of a large number we wish. We are understanding it about with help of example. Find the square of 1, 2, 3, 4 by Dvandiyog method. Now first we have to making groups for it. The similar in the case of Urdhava Triyak Bhyam, we are taking the first digit and then 2, then 3, and then 4. When we are reaching the maximum, then we are removing one digit from the left hand side. So you have to do the same thing here. where we have to find the square of 124. So first we are writing the 1, then the second will be 1 2, then 123, and then 1 2 3 4. We are reaching the maximum number. Now what we are doing, we are removing one number from the left in the next each step. The next is 234, next is 34, and last is 4. So how many groups are there? There are 7 digit groups of 123, 1 2 3 4. Now what you have to do, you can see when the digit is single, you have to square it. Whenever a digit is single, you have to just square it. When you get any digit in pair, and here you can see 1 and 2 are in pair, so you have to multiply them. 1 multiply 2 and also multiply it by 2 again. Why we are multiplying 2? We are finding square, so we multiply it by 2. So 1 multiply 2 due to this pair, and the next multiplication of this formula of this segment. Now we are moving the third pair. It is 1 2 3. Now we are making the pair. The pair always between first one and last one. Here first one is 1 and the last one is 3. So 1 multiply 3. When we are multiplying, we have to multiply it by 2 also. So 1 into 3 into 2 plus 2 is single. Here 2 is single. So what we have to do? We have to just find square of it. We are writing plus 2 square. Now we are moving on the next group. Here 1 2 3 4. What we have to do? The concept is same. We have to multiply the first one with the last. So the first one is 1 and the last one is 4. So 1 into 4 into 2 plus 2 into 3, because here the first one is 2 and the last one is 3, because 1 and 4 are already used. So now the group contains only 2 numbers, 2 and 3. So here the first one is 2 and the last one is 3. What you have to do? You have to multiply them 2 into 3, and whenever we multiply, we also have to multiply it by 2. So 2 into 3 into 2. Now we are writing a slash, then we are what we are doing 2 3 4. Here the first digit is 2 and the last digit is 4. What you have to do? We have to multiply 2 multiply 4. Whenever we multiply, we also must have to multiply it by 2. So 2 into 4 into 2 plus what we have to doing here, the single digit is here 3, so we are finding its square plus 3 square. Now we are moving the next one. Next digit is 3 4. So what you have to do? 3 into 4 into, whenever we are multiplying, we have to multiply it by 2. So 3 multiply 4 into 2, and here the last digit or last group is 4, so it is single digit, so we are finding its square, 4 square. Now when we are solving it, what we are getting these numbers. And when there are two additions, first we have to add 8 plus 12, then we have to add 6 plus 4. When we are adding, we are getting these numbers. In this concept or in this method, we are only taking a single digit number, all other digits will be sending forward. So here you can see all the next digits will be writing in the subscript. We are sending them one by one, and after it the final answer is 1522756, and this is our final answer. Hence the square of 1 2 3 4 by Dvandhi Yog method is 1522756. And also you can also see all the general things in this concept or in this table. Here you can see we are getting a single digit. What we have to do? We have to do it square when there are two digits, or you can say it is AB. What we are doing with AB? We are multiplying A into B into 2, because 2 is the digit or 2 is of the its formula. After it A B C, what you do? We multiply A into C into 2 plus B square, and this concept will be used in each and every group. I think you all understand the concept of Dvandhi Yog easily. Now we take a look on next concept. The next is Ishta Sankhya method. Now what is Ishta Sankhya method? Ishta Sankhya method is also pronounced or also called as Sutra Sanakalan Vyakalan. So this concept contains a general formula. It is x square equal x plus a multiply x minus a plus a square. Here x representing the number whose we have to find the square, and a is representing the unit digit of it. So here you can see that we have to find the square of 12 by using Ishta Sankhya method. What we have to doing? We have to first writing what we have understand from the question. We understand that according to question we have to find the square of 12 by using Ishta Sankhya method. Then its solution is below. Now as we know that x square equal to x plus a, x minus a plus a square. You have to highlight it. After it you can say here x equal to 12, because of which number we have to find the square? We have to find the square of 12. So here x equal to 12 and the unit digit is equals to, so a equals 2. Now we are substituting the corresponding values in the formula. What is it? X is at the place of x we are putting 12 and at the place of a we are putting 2. So here you can say x plus a, it means 12 plus 2, and x minus a, it means 12 minus 2 plus 2 square. 12 plus 2 equals 14 and 12 minus 2 equals 10. 14 into 10 equal 140 and 2 square equal to 4. So 140 plus 4 is equals 144. As the square of 12 by Ishtu Sankhya method is 144. As you all know, the square of 12 is 144. I think you all get the concept.